Welcome back. Today we're doing a deep dive into something fundamental, energy transformation.
Yeah, how energy changes form all around us.
We've got some great material looking at this in nature, in technology, everywhere really.
Exactly. And the mission today, let's try to trace how these energy shifts happen based on what we found.
Okay, sounds good. Where should we start? Maybe with the classic example, a leaf.
Perfect. Photosynthesis. So imagine sunlight that's radiant energy, electromagnetic radiation.
Visible light, yeah. Hitting a tree leaf.
Right. And that light energy drives the whole process. It allows the leaf to take water and carbon dioxide.
And turn them into glucose, sugar, essentially.
Precisely. And that glucose molecule now holds chemical potential energy. The sun's energy is now stored chemically.
Like a tiny biological battery.
You could say that. What's interesting, though, is the efficiency. It's quite low.
How low?
Typically, only about 3 to 6% of the light energy that actually hits the leaf gets converted and stored.
Wow, that's
Yeah.
not much.
It doesn't sound like much now, but the sun puts out so much energy. Our sources mention that even if only 1 part in 2 billion of the sun's total output hits the leaf, that small fraction is still significant enough to power life.
Huh. Okay, that puts it in perspective. So that stored chemical energy, it doesn't just stay in the leaf, right? It moves up the food chain.
Exactly. Let's think about crops. They do the same thing, photosynthesis, storing chemical energy.
Okay, so fields of stored sunlight.
Then, say, a cow eats those crops.
Right.
The cow breaks down the plant matter, releasing that chemical energy. It uses some for movement that's kinetic energy, and some to build its own body, its biomass.
Which is more stored chemical potential energy.
Correct.
Yeah.
But, and this is key, the transfer isn't perfect. Far from it.
Energy is lost.
A lot of it, mainly as heat from the cow's metabolism and also in waste, like undigested material. Energy transfer between trophic levels is generally quite inefficient.
Got it. So if a human then drinks milk from that cow,
We're ingesting the chemical potential energy stored in the milk, fats, and sugar.
and we use that energy for, well, everything. Moving around
Kinetic energy, yeah.
and just staying warm, maintaining body temperature.
Which is thermal energy. See? It's a constant flow and transformation.
Okay, let's shift gears a bit. What about non-living energy sources, like fossil fuels, crude oil?
Ah, yes. Our sources describe crude oil basically as stored ancient sunlight.
Ancient sunlight. How so?
Well, think about it. Crude oil comes from organisms, tiny plants and animals that lived millions of years ago.
Okay.
They captured the sun's energy through photosynthesis, just like plants today. Then they died, got buried, and over geological time, heat and pressure transformed their stored chemical energy into oil.
So when we pump crude oil, we're tapping into sunshine from millions of years